Hello, welcome to this MagiCAD for Revit webinar. Today we're going to look at the sprinkler modelling and calculation tools that exist in the piping and also the sprinkler calculation engine modules. We're going to take a bit of a look at the overview of the calculations rather than go in deep detail about it, but hopefully you'll be able to get an understanding of how the systems are created and how the calculations are performed. And if you want any more information about that, we can go into more detail in an individual demo for a company or webinar. So before we proceed, I just want to make a note, this is not a training session, so don't expect anyone to come out of this webinar and understand exactly how to drive MagiCAD and piping and sprinkler calculations. So we obviously have a highlight view of the module that we're doing today, but if you want any more information and want to proceed with it, then obviously full training is something we recommend highly, or if not, almost require to use the software. Also, just while we're on, I just want to touch on other modules that we have available. You can see on the screen we have vent, piping, elec, schematics, as well as a sprinkler, and it also supports and hangers. So if you want any more information about those, just inquire as well. I'll give the details at the end. And also we offer a whole range of training and consultancy services. As part of our services, we can provide customized solutions for any company. So again, if you need these, just get in touch. So let's go into the actual live demonstrations. So just for those who are maybe not aware, the sprinkler calculation engine which exists in here is actually the module that you would purchase. So the actual engine, unlike the other modules where the calculations come with the vent, pipe, elec, schematics, this module, actually the engine is the module you pay for, and with that we'll include the piping module here as well, so you have full access to all the piping, like modeling, coordination tools, as you'd normally have with the piping module. I'm not going to touch on these today, it's covered in other videos, but the piping module coordination tools, so crossing, move and copy branch, angle to horizontal, they should be familiar to any MagiCAD users previously. But for anyone new, these are a very, very handy set of sort of enhanced modeling tools which are used continuously when you're modeling in 3D environment such as Revit. So I'm not going to go in detail about these, but just be aware they do come with the piping module as well. And of course you get the whole range of our products in our library as well we can use with the sprinkler module as well. But the actual sprinkler, like I say, if you bought the piping module, you wouldn't have access to the sprinkler calculation, but you would have access to these. But when you buy the sprinkler calculation, you have access to these tools here in piping. So I hope that's clear for you. So first of all, let's have a look at sort of a scaled down, simplified process of how we run a sprinkler calculation, how we set up the system in the first place. So what I'm going to show you first is how to install sprinklers. You can see I've already got some heads already installed in here. I'm just going to give you some very quick examples of some extra functionality that we provide in order to install sprinkler heads. So here's some examples from our library. Again, you have access to all this, so you can download this from the cloud. I'm not going to show how that's done, it's covered in other videos elsewhere, but here's some example sprinkler heads from our library, and you can set these up as part of this to use, so you have operational area and things like that, and choose your own symbol. But for now I'm just going to dive straight in, press OK to install that particular sprinkler, and you can just dump this wherever you want. That's our normal sort of Revit type manual installation. I just want to show you a couple of things that might be quite handy when you install sprinklers. Firstly, we've got this dialog box, and you can choose which system you want to put it on. So in this case, we've got fire protection wet, and this sprinkler system here, that's just the Revit sprinkler systems definitions that are coming through. And for the sprinkler calculation, area of coverage, the required flow density, and the required pressure level at the sprinkler can all be defined in here, and that will affect clearly the calculation as we run it later on. So I'm just going to leave these values as I've got them set up in there for now. And you can also set the orientation here, the sprinkler head pointing downwards. So again, you can just dump it freehand if you want. A couple of nice things that we have. First of all, you can click on ceiling. Sprinklers are many times, very often installed in sprinklers. The head's pointing down from the ceilings. So if I click on this particular ceiling here, all I need to do is just define my grid layout. So I'll just click the 3 points, and then I'll just click in there and maybe in there or something like that. And you can see how that works. It actually puts the sprinkler head center in the tile. For those who don't use Revit very often, you might think that's quite a basic command, but Revit itself lacks that ability, so you'd have to try and figure out exactly with detail lines how to coordinate that in the center of the grid. Incidentally, this ceiling function works for any level-based device that is installed through the MagiCAD tool, so not just sprinklers, just so you know. But you can also install a bit more automatic than that if you want to. Clearly, there might be some rules you want to follow in terms of sprinkler head coverage and things like that, and operational area. But if you just knew that you wanted to install a sprinkler head in the centre of a tile because you're happy with that, then you could use that and just put one in there. We could also install by array as well, so you could also install a sprinkler head by different functions in here about choosing X by Y quantities of sprinkler heads. But I'm just going to show another ceiling one. So click on ceiling, and it's a bit more auto definition. You can click on the ceiling itself and choose the tile at which you want to use as a definition for that. And you can see there you can change the number of rows in between the sprinkler heads. So I want to go with that one, press OK, press apply, and you can see it then puts the sprinkler heads in like that. So quite straightforward really, but it's quite a handy tool, that, especially, I mean, you can see these haven't been coordinated with the ceiling previously, but using that tool that would achieve that a lot easier, so that wouldn't be a sprinkler head clashing with the T-bar of that ceiling tile hanger there. So a useful tool. I'm just going to come out of here now and go back to my normal plan view. Next thing I want to show you is the operational area. So what is quite handy, if we go into this operation area, it can show the operational area of the actual sprinkler. So you can see in there that if you've got the space defined, the actual operational area will be limited at the space perimeter there. So it makes you aware of the coverage of that sprinkler. So that's obviously a function of a radius, which is a function of the area of coverage. So if you're happy with that, it may be that you wanted this to extend out of the room, and actually that isn't going to be compliant. Then obviously you can change that to have an increased area of coverage. So that would be to the corners of that space. So it's quite a handy tool again to have just as a double check visually to see if the sprinkler heads that you're putting in do match. And obviously if you want overlapping sprinkler head coverage, then clearly if that was like 4 in a row in a space, then clearly these would just slightly overlap here and here. So great, again you can use that to determine that as well. If you want to turn them off, then just press hide, and then in that view it'll just turn them all off again like that. Okay, the next sprinkler function I want to show is the connection of sprinkler heads to pipework. Using basic Revit tools like out-of-the-box Revit is extremely fiddly to set these up and model it accurately, especially when you've got offsets and like raised connections off other pipes and raising again off the pipe onto the sprinkler head, etc., which is quite a common way of connecting sprinklers up to minimize or eliminate like sediment and things like that. You have a raised pipe coming off into the sprinkler head. Very fiddly in normal Revit. We've got some great tools here to help with that. So if I go into this sprinkler connection tool here, for example, I can drag a window across here. I want to connect in an inline, so I'm coming off the side of a pipe, for example. Choose my sprinkler heads, press finish, and then choose the pipe I want to connect into. And then you can see here, you get a little bit of a preview about how that's going to look. You can see in plan view as well how that works. But you can see in here that we're going to come off the main pipe and then come off the end if you want to do that as well. Don't have to. And you can change these heights, however you want to change this coming off. So I want to come off, say, 250, just regenerate the view, and it will just reconfigure that layout just to suit those figures in there. And then you can choose how the sprinkler heads, like the final connection, is done at the end. So you want to have these offsets, then you can. If you don't want to have these offsets, then you don't have to choose them either. And you can choose if you want to have flexible pipe on the end of it or not as well, and put the flex on the end. If you're happy with that, just press OK, and you can see that now it's put my sprinkler heads on as in the preview. And then now what I want to do now is create another sprinkler connection, but this time I'm going to do like an antenna type. I want to come off the middle of this pipe here, let's say. So press OK on there. And what you'll see when the preview loads up, that we should now have a different configuration. You can see it's like a centered connection. So you can see in the 3D it raises up off that center point where I define that connection to be made, and then tees off to the individual sprinklers. You can see now it's also rising off the individual pipes to the sprinkler heads. And again, like I said, you can change all that if you wanted to. You can change this, how that's done. You can change the heights at which that comes off. So if I change that to say 150, it will reduce that the height of that tee off for those individual sprinklers there. You can see loads of different configurations, of course, loads of different ways of interacting with this, but I also want to give you a quick overview about some typical arrangements. And then when you're happy with that, then just press OK. And then there we go. There's a nice antenna connection, and you can keep going like that. So you can imagine trying to create that arrangement in just manual modeling with Revit would just take you, that would take, I wouldn't like to guess, but it would take a lot longer than a couple of minutes, as we just showed there. Each one of those would be very, very fiddly to draw manually. So I just want to give you a quick view of those and how they've been created. So that's how to set up a sprinkler system. You've seen how to install a sprinkler head or sprinkler heads. You've seen you can put some definition in there of some values for flow and density and coverage, and then you can use those in the calculation, obviously. So I'm just going to move down here where I've got a slightly more realistic sprinkler system set up. And the way it works with MagiCAD in Revit to do the sprinkler calculation is there's a couple of things you've got to set up. Firstly, design areas. These are areas where you have sprinkler heads, and you can have as many sprinkler heads as you want in these design areas, and it will tell you the weakest sprinkler head in that design area. So in this case, I've got this design area 1 and 2 here, and in this I've got like 1, 2, 3, 4 sprinkler heads in there, obviously same in design area 2. If I had a design area that only covered this part here, then I'll have 2 sprinkler heads in there. Or you could drag a design area across everywhere. But as a designer, as a user, you'd be looking for these like sort of weakest, or like index root is another way of saying it, weakest sprinkler heads, and you can just create a couple of design areas and see how that works. You can also set up, if you have a naming convention of these design areas, you can see here, and these are MagiCAD design areas, by the way, they're set up by MagiCAD. I'll just quickly jump to that. You just go into calculation control and create design sprinkler area, and then you just draw the box around it, like that's all I've done. And these have names, so you can see them there. And all they do is, if you want to have 2 different locations with the same design area, not sure about which might be the worst case scenario, then you just set up, so I've got design area zone 2 and zone 2 here, and what it'll do, it'll use the sprinkler heads in those areas to set up the design area and report back which is the weakest head and which is the index root and all the pressure details for all those sprinklers contained in there. If you have sprinklers that aren't contained in design areas, then the calculation ignores them. So you don't have to have like an entire building with thousands of sprinklers being calculated at once. It obviously be quite heavy to sift through all that data when you know that the likely design areas of weakest are probably on like the top floor, let's say, with, you know, on a 10-story building, be like near the top floor towards the end or something like that. So you could just choose a couple of design areas in those worst case places and then review those. So that's how to set up the design areas, and then you draw the sprinklers, as I explained before when I showed you how to install them into the ceiling, or do it manually, it's up to you. Then you connect up the sprinkler heads using the tools that are shown. And then once you've done that, I'd like to just go to our settings so you can see how you can configure the calculation standards. So in here you can see we've got a list of calculations standards for sprinklers, so EN 12845, CA, NFPA 13, BS 9251. So quite a few in there. Obviously some other, there's like Italian, Malaysian, Singapore, Australia. So you see it's quite well covered. So we're looking at the UK market here in this particular webinar, but obviously they could apply to other markets as well. So I'm just going to proceed with 12845 in this particular example and press OK. Of course you can change that if you want to change it to a different standard, and then you can change that and recalculate it to the new standard, not a problem. So once I've done that, I can then run my my calculations. So I can do sprinkler sizing, I can do sprinkler calculation. Now the sizing, I just want to quickly touch on that. That's something you configure in the data set. You can see here that you set your sprinkler sizing methods in here. Without going into too much detail, what this is doing is defining the size or the maximum size of the pipework in accordance with the number of sprinklers connected at that point. So as you can see here, as the sprinkler numbers summate through back up the system, the size of the pipework can be increased accordingly. And you just set that against the number of sprinklers in that system or in that network connected up. And then I'm just going to run it over here so you can see it in action. So sprinkler sizing, and then press OK. And then on this particular system here, you can see how it now incorporates those newly connected sprinklers into here, and you get an indication of the pipe size and the number of sprinklers connected. And just press OK, and you can see that the pipe size, it starts off large, 100 mil in this case, I think it was, all the way down to the final connections. So it'll just resize that pipe work you can see there, and then as it comes through, you can see how it's, you know, reducing onto those final sprinklers there like that. So that's how that works. It's quite straightforward, but then you can just define that however you like on your project for each network. So let's look at the actual calculation itself. If I just press sprinkler calculation here, and then choose the connected network, which is clicking this pipe here, and then what it will do, it'll run through that network, look for design areas which are incorporated with the sprinkler heads inside them. So it's found 2 zones which we know are design area zone 1 and 2. We've got them here, and you can choose your standard. It defaults to the one in settings like I showed you just a minute ago, but you can also choose a different one at this point as well. Very quickly, just touching on these, you can choose whether you use Hazen-Williams factor or Darcy-Weisbach factor. Then if you use Darcy-Weisbach, you can choose the fluid and the temperature. I'm going to go with Hazen-Williams in this case. Then you can balance the minimum pressure. We recommend you always do this first, so you can get an idea of the actual system pressure. Then you can add a pump onto here as well, and you can also put your own feed point pressure. And if you know what the actual fixed pressure is, you can do that and see what the outcome at the sprinklers is in terms of pressure and flow density, etc. A few options down here. You can ignore branches shorter than. So if you have a sprinkler, say bolted onto, or it's not bolted, that's the wrong word, connected onto the side of a pipe that's welded in, then you could just ignore that branch and just say, well, it's a sprinkler connected to the actual pipe itself, even though in Revit you've shown a physical bit of pipe sticking out. You can choose to have a welded definition from a certain size, so 50mm upwards could be welded, so then you have a different set of equivalent length factors as well. And also you can show a warning if you want to set a velocity in there and say that warn me if it's higher than this, etc. So you can define that however you like. For now, I'm just going to press OK, and that'll run through the system and then pop out this sort of general results report. So you can see in here, this is design area 1. In this drop down, you can see that I've chosen that one. Interestingly, one thing to note in here, it does tell you your minimum pressure in here. So I know out of these two sprinkler zones, like 1 and 2, I know that the most onerous actually is sprinkler zone 2 because it's got a higher pressure requirement. So I might want to concentrate on that. So it's very handy having that there in the summary. So if you had like 10 different zones, instead of having to go into each zone and look at the pressure in each one, having that summary at the top can alert you immediately into where the worst case sprinkler likely or definitely is according to that pressure there. So I'm going to look at this one, and I'm not going to go through it in detail. I haven't got time in this brief webinar to go into detail about it, but some of the key points we want to look at in this report. First of all, these sprinkler numbers. So when you have the actual numbers itself, you can see they're referenced in the view behind. And if you look at like the 4 weakest sprinklers, that's what these numbers are meaning. So 25, 21, you can see they're indicated in the view behind. So you've got a bit of a reference, so you can see where these actually physically are located. And some of the key things are pressure at the feed point. So that's back here, right at the very start. So I need 644 millibar to achieve the density that's required, and the flow at the feed point, etc. And then you can see here, the next one really is key, is flow density at weakest sprinkler is 8. I think I wanted 7.5 according to, well, I'll show you that in a minute. So I'm well covered there. The average density of the 4 weakest sprinklers is also indicated where they actually are referenced, the weakest sprinklers, average flow density, etc. So that's the summary of that particular calculation. Then you can look at the sprinkler results. So in zone 2, I can see that there's my particular sprinklers. I can see there that my weakest sprinkler is number 25, which in the view is back here, and I can see that my actual pressure at that is 500 millibar as defined on the sprinkler when I put it in. And you can see the actual pressure required is 500, but you can see that obviously it's increased in the other ones because obviously it's a higher pressure because they're not on the index route. And it'll tell you your flow density required, but the actual flow density will be indicated here in this column, so you can see what it actually is at that pressure. So it's giving you a full summary of each individual sprinkler and its behavior and its performance at each sprinkler based on the requirements of the system and the sprinkler heads themselves. And then going to system results, this just runs through the actual connected system, and you can see the actual the section numbers from 1 to 2 to 3, what's happening in each of those, the K factors, the velocity, and the pressure at the start, all the way down to the weakest sprinkler head, etc. So you can see here to this, that's repeating the same information again, and just for that one sprinkler there, so you can confirm that 500 millibar is in fact the case at this number 25. So it should give you a full overview of the sprinklers and the performance throughout the system based on the general results, system results, and the sprinkler results. And finally, you have the equivalent length values as well, so whether you have threaded or welded tees and bends and fittings, and it will tell you the equivalent lengths used from reference tables for the individual sizes and types of fittings in there. So if you're happy with that, then you just press OK, update to model, and it'll put all that information into the actual pipes and sprinklers and fittings in that system. So that's now been calculated, so it can be referenced and tagged or analysed on an individual basis. If you click on individual fittings, or pipes, you can see the actual flow data in there if you want to have a look at that as well. I think that's it in terms of the sprinkler calculation reports. Obviously, we could go in a lot more depth as per training, but hopefully that's just given you an overview of how the sprinkler systems are created, connected, analysed, design flow areas, and then obviously the hydraulic calculations performed to give you the full information for you to make an informed decision and to print out those reports for your calculation requirements. So if you like any more information about this and like a demonstration, or you want to proceed with a trial of the software, then we can actually do that for you. So if you want to get in touch with us, you can contact us on the information on the screen now. So if you want to arrange, like I said, demo, trial, whatever it is, please get in touch and we'll go from there. But for now, thanks very much for your attention, and we'll see you on the next webinar. Thank you.